Assalamu alaikum students. I'm Dr. Amreen Ayub, and this is your lecture 5. You know that we started a new chapter, that is plasma as fluids, and in this chapter we already discussed two topics. That is, we already discussed the topic fluid equation of motion, and in fluid equation of motion we discussed the connective derivative, the temperature effects on the fluid equation. We find out the equation of continuity, equation of state, and we have to find out the relation of plasma physics to ordinary electrodynamics. In electrodynamics, the main equations we studied are Maxwell's equations, and here we have to find the relation of plasma physics to Maxwell's equations in vacuum and in a medium. Now, the Maxwell's equations in vacuum and Maxwell's equation in medium. Maxwell's equation in vacuum are del cross E is equal to minus B dot. Del cross B is equal to mu naught J plus epsilon naught E dot. Del dot E is equal to sigma over epsilon naught, and del dot B is equal to 0. Now the Maxwell's equation in medium are del cross B is equal to minus B dot, which is the same equation as of vacuum. In the second equation, del cross H is equal to J plus D, and in this equation the difference is that we use H in spite of B, and B is equal to mu naught H, and we use D in spite of E, and D is equal to epsilon naught E. So del dot, the third equation is del dot D is equal to sigma, and fourth is del dot H is equal to 0. Now in equation 6 and 7, J and sigma stand for the free current and charge densities. The bound charge and current densities arising from these are basically the bound charge and current densities arising from polarization and magnetization of the medium. And when there is magnetization and polarization, we use D and H in terms which are in terms of epsilon and mu. So D is equal to epsilon mu E, and B is equal to mu H. But in our plasma we know that the ions and electrons comprising the plasma are equivalent of the bound charges and currents. Since these charges move in a complicated way, it is impractical to lump their effects into two constant epsilon and mu. So this means that we do not use epsilon and mu for the representation of ions and electrons in plasma. So consequently, we in plasma physics we generally works, and we also know that in plasma physics we generally works with the vacuum equations 1 and 4, in which sigma and J include all the charges and currents, both external and internal. We also use Maxwell's equations in vacuum also because in plasma physics we use Lorentz force, which is equal to this m dV by dt is equal to Q E plus V cross B, and we have used E and B here, and these are used in vacuum equations rather than their counterparts D and H, which is related by the constant epsilon naught and mu naught. That is, D is equal to epsilon naught E and B is equal to mu naught H. So basically in plasma physics we use Maxwell's equations in vacuum because in these equations we have electric field and magnetic field, and these electric field and magnetic fields are also used in Lorentz force, which we used in the derivations of plasma physics.